Hi, this is a presentation for the project developed by Team 214. My name is Tanvi and I will walk you through the basic functionalities of our system. We have developed a web-based application called Plagiarism Detector, which is also deployed on AWS. The application helps instructors detect plagiarism in code submitted by students. The main goal of our application is to assist the professor in filtering out possible plagiarism cases. In our application, the professor controls the comparison process and he can choose to trigger the plagiarism detection functionality as he wishes. Here is the main page of our application. An overview of the application functionality. There are two roles defined for users in our application: student and professor. A student can log in into his portal and upload files for an assignment. Currently, we're detecting plagiarism for Python files only. A student can also upload multiple files in a go as seen here. The professor has a separate portal. After logging in, the professor can choose an assignment he wants to investigate further into. He is presented with a list of student submissions. The professor can then choose two students he wants to compare and run the plagiarism check on. After doing this, the professor can also choose a strategy to be used for comparison. We have implemented three strategies on demand: longest common subsequence, cosine, and combined strategy. After choosing the two student submissions and a strategy, the professor can hit the compare button. The result will be displayed to the professor. My teammate Aditya will now explain the results and what we have achieved during our sprints in this project.
Thank you, Tanvi. So before I get into the results, I would like to point out another optional functionality that's available to the professor. He can get the email sent to him with the results in it by entering the email address here and then hitting the compare button. The email is sent from plagiarismdetector214@gmail.com and it has this kind of a format. The result page consists of one-on-one comparison of all the files submitted by both the students and the degree of plagiarism that might exist in them. A quick recap of the functionalities implemented by the team. We were able to implement three strategies for comparison, one of which was a combined strategy deploying both of strategies implemented before and getting a combined score from them. Also, we are able to send emails to the professor when he may desire. These functionalities can be tracked on Jira as a collection or individually distributed amongst the sprints. There's functionalities that were implemented in Sprint 1, Sprint 2, and Sprint 3. We maintain good code quality by using multiple utilities like GitHub Checks, Jenkins Continuous Integration, and SonarQube. These helped us ensure that at each point we made commits which were sustainable and well tested. Now Deepak will go into more details about how we used these utilities and also our experiences as a team.
Hi there, this is Deepak. So, starting with the teamwork and the processes, it begins with the team meetings, the periodic discussions, and finally assigning the tasks to each individuals on the Jira, where we call it issues. To manage our code, we use the GitHub as our version control system, where we had the smart commits enabled as well. And to keep everything organized, direct merging to the master is blocked without the approval of another teammate and the passes of the continuous integration checks. These checks were set up through Jenkins, which automate the building and the testing. So the Jenkins goes through a particular set of phases for every time we commit, and only if all those checks get passed, It allows us to push to the master. It also keeps tracks of the recent versions we have pushed, and thereon we can see the progress we have achieved throughout our cycle by improving our code, by improving the structure and the logic. To track the quality of our work, we have also looked into the SonarQube reports that shows the stuff like bugs, code smells, coverage, and duplicates. All in all, it was an agile development process where everything is divided across multiple sprints and our focus used to get changed based on our needs and demands. Carrying on with the technologies and the future work, I'll pass on to Mihir.
Hello everyone, my name is Mihir and I'm going to explain the technology stack we used, the problems we faced as a team, how we solved them, and the future scope of this project. We found Voltaire's saying that the perfect is the enemy of the good to be true. Good enough was our goal for the project, and I'm happy to say our system effectively detects plagiarism between student submissions for Python files. We developed our project in 3 sprints of 2 weeks each, where we updated our daily goals on Slack and used Jira to assign issues. The problems we faced during the development of the project included deciding when to stop looking for new options to implement the system, deciding the order of things that needed to be done, how to automate steps that need to be repeatedly performed, when to invert priority of tasks, and deciding which problems are tractable for our system. We solved them by using the 37% rule for optimal stopping, choosing explore versus exploit option based on the time we had to perform that task, using Jenkins to automate the task of only being able to push code that passed the quality gate of SonarQube, and that too after another member of our team approved the merging to master, choosing the priority of tasks based on the tasks that they are blocking, practicing constraint relaxation for large problems, and using the Cobham-Edmonds thesis to decide between intractable versus tractable changes for our system. The technologies we used in the project include GitHub for version control, Jira for issue tracking, Jenkins for continuous integration, SonarQube for code analysis, AWS for deployment, and Spring Boot for application development. The future scope for the project could include displaying parts of files that have plagiarism, providing support for other languages, providing functionality for comparing files from previous semesters, providing functionality for comparing different sections of the same course, performing A/B testing for a fixed number of users. Thank you.